Whether you are a parent, another teacher, or a dedicated student, this is an important video for you to watch, especially if you're about to enter your very first algebra course. I've been teaching algebra for a while now, and I've realized there are some very important skills. Actually, they're needs, they are necessities, things kids have to know before they come into my room, or it's going to be a very long and difficult year for them to pass Algebra 1. Okay, we're going to start off with just multiplication and division, knowing our times tables, knowing our multiplication. If you don't know that, you're going to have a tough time. Okay, so let's say you don't know your times tables. It's 8th grade year, you're about to enter Algebra 1 in your 9th grade year. And if I were to say 8 times 7, you don't have it like that. That's an issue. And the reason that's an issue is because you're going to have to do multiplication of values 0 through 10. I mean, it's just constantly something you're going to be doing. When you're trying to solve a two-step equation, you got to know your times tables just to go step by step by step and go through it. Now, this is going to play itself out over and over and over again all year long until you start to have them memorized. That's right, I said memorize. Flashcards is hands down the best way for you to get there. So make a group of flashcards, a set of flashcards of specific multiplication problems you don't know, and then you need to do those at home. Students, if parents, encourage your kid to practice daily until you can throw any two numbers at them, 0 through 10, 8 times 5. If they don't have it immediately, you keep working. You keep working, you keep working, you keep working until they have it down immediately. So multiplication and division, that is the best route to go about it. The next one on my list is kind of a tricky one, okay? This is going to take some actual teaching and understanding of the students, and that's adding and subtracting integers. So if you're not sure what an integer is, that's like 5 minus a negative 4, okay? So negative values get introduced. Integers basically include anything to the left side of 0 on our number line. So prior to that, we have our natural or whole numbers, but when we introduce integers to kids, now we're talking about negative values, and this can really throw off some thinking, okay? Because now when I'm asking you to subtract, your number's actually going to be going up and increasing from 5. So 5 minus negative 4, double negatives here really means a positive. You're actually adding a value of 4 to this to get 9. Now this is a difficult thing for kids to understand, so I'm going to break it down and show you some pictures, some images that I draw often in my classroom to help them understand the concept of what's actually happening. All right, so big one for me, let's give me a problem like, let's say 6 minus 10. All right, so if I say 6 minus 10, we're going to drop into the negative values because 10 has more of a value than 6, and the 10 term is negative. So how would I show this in an image for the kids? I draw a picture of a ladder. I like to start with the ladder and say we're 6 feet above the ground. So you're up here at 6 feet. 6 feet is our starting point. We're going to drop 10 feet. So we're dropping 6 would take us back to the ground. Now we've already dropped 6 feet. How many more feet do we need to drop to go down a total of 10? We have 4 more to go, so we are at negative 4 as a final result. Okay? There's one example. So you could do ladders up and down. Now if you start at a negative value, I like to draw a hole. So let's say I say negative 6 minus 10. Okay, I like to say here's the ground, here's a hole that you dug, and we are negative 6 feet underground. You grab your shovel, and because we're subtracting 10 more feet of dirt, we're going to go 10 more feet down into the ground. Well, we're already 6 feet down, 10 more feet would take us all the way back to negative 16. Okay, so those are images that I like to draw. So like something that rises and drops, elevators, you could do sea level. Sometimes I'll draw scuba divers going up and down. If we're below 0, sea level would be 0. And then the number line. The number line's a go-to as well as an image. I'll show you an example of that right now. All right, so we've hit on adding and subtracting integers. Now we've got to talk about plotting points. So one of the things that I have to have my students be able to do is plot a point. So if I give them an ordered pair of negative 2, 3, they need to understand that that negative 2 is what's going to tell them to go left or right. Okay, that first value is your x value. That's your movement left or right on the x-axis. So we're going to negative 2, that's left 2 spaces, and then up 3 because 3 is going to be our y value in the ordered pair. So we're going to go 1, 2, 3 up, and that dot should fall right there. A lot of times I'll see kids with this value and they're gonna put dots down here. Sometimes I have them there, sometimes I have them there, I get them here. They get them all mixed up, but the breakdown really just comes to understand that that's your X, that's your Y. You're always going to crawl before you climb. So I like to say babies crawl across the floor before they ever learn to climb a ladder. Okay, X before Y. You can also just look at the label. X, Y, X is -2, so go to -2 on the X-axis, go to +3 on the Y-axis, place your dot there to do it properly. Okay, why is that important? Because I'm gonna teach you how to graph, and if you don't know how to plot a point, graphing is gonna be dang near impossible. All right, after that, solving 1- and 2-step equations. 1- and 2-step equations are very basic equations. You're just using inverse operations, so really you're just either gonna be adding or subtracting, and then multiplying or dividing to solve. Okay, so 1- and 2-step equations, really just those two operations are coming into play. There's not much more with it. Let me give you a couple of examples. 3x = 9. They need to understand that this is saying 3 times x, so we need to use the inverse operation of multiplication, which is division. So we divide by 3, and in one step, we now have our answer of x would have to be 3 to make this equation true. That's a 1-step equation, excuse me. Now a 2-step equation will look very similar to that. 3x + 5 = 18. Okay, so if we did that problem right there, now what we're going to end up getting, well, let's do 17, sorry. Make it a nicer number to answer at the end. So there we go. This is a 2-step equation because I'm going to need to get rid of the 5. I'm also going to need to get rid of the 3 so that x is all alone. We're always just trying to isolate the variable, get that variable all by itself. Take away 5 because the opposite of adding 5 is subtracting 5. That's going to cancel. Take it away over here, leaving me with 12 = 3 times x. Because that's multiplication, we use division. Boom, boom, shakalaka, boom. Now we know what x is, and we're ready to go. So that's a 1-step you saw first. This is a 2-step, which I just showed second, because it takes 2 steps to get x isolated. And last but not least, they need to know their perfect squares 0 through 100, because you're going to be taught Pythagorean theorem, if you haven't been taught it already. And we're going to start to do some things with square roots. So square root of 25, they need to understand why the square root of 25 comes out to 5. They need to understand why the square root of 36 comes out to 6. They need to understand why the square root of 64 comes out to 8. Okay, so these are basically the ideas, the things that I have to have the students walk into my classroom with already. If they already have these, I can promise you the year is going to be that much easier. It's a big difference between a kid that has to relearn this stuff and a kid that over the summer didn't forget it, or they practiced it, a week before school started. They went back into doing some math to remind themselves of it before they came into the classroom. Because if you're in Algebra 1, you're going to get started pretty quickly. First week of school, I'm going. We're ready to roll. So get ready for it. I'm excited for the year, and I hope you guys all are too.